Assalamualaikum. My name is Anam Javed and my registration number is 16T82. Welcome to the lecture of digital signal processing. Today we will discuss what is moving average filter. It is simple and common filter in digital signal processing. Its operation is based on averaging a number of points from the input signal to produce each point in the output signal. We will implement moving average filter by using convolution. In equation form we can write moving average filter as y of I equals to 1 divided by m summation j equals to 0 varies from m minus 1 x of I plus j, where in this equation x of I plus j is the input signal whereas y is the output signal and m is the number of points in the average. Now let's consider an example in which a 5-point moving average filter is designed for 80 points in the output signal, and it is written as y of 80 equals to x of 80 plus x of 81 plus x of 82 plus x of 83 plus x of 84 divided by the number of samples, that is 5. It can be alternatively written as the group of points from the input signal by writing a symmetrical around the output points. As we want to calculate the 5-point moving average filter of y equals to 80, we will just consider it as a midpoint and equally writing the samples before and after this point, that is x of 78 plus x of 79 plus x of 80, this is the midpoint, and then consecutively writing the two samples, as we write two samples before x of 80 and we have to write two samples after x of 80, that is x of 81 plus x of 82 divided by the number of points, that is 5. Many scientists and engineers don't prefer the moving average filter because it is very simple. Whenever they come with a problem, they first apply the moving average filter, but they are not in favor of using a moving average filter and in search of something complicated. Now we will apply moving average filter to study the noise reduction versus step reduction. The original signal is given as shown, and when 11-point moving average filter is applied, some of the sharp points are reduced, but there is still high frequency components involved in it. As we increase the moving average filter points from 11 to 51, the sharp edges are reduced and smoothness is achieved. As it is written, the signal is filtered with 51 points moving average filter respectively. As the number of points in the filter increases, the noise becomes lower. However, the edges become less sharper. In the previous one, there is high transition due to high frequency component, and by increasing the number of moving average filter, smooth transition is achieved. The next is the frequency response. Frequency response for the moving average filter. The moving average filter has a very poor low pass filter due to it has slow roll off and poor stop band attenuation. These curves are obtained by the formula given as h of f equals to sin pi f of m divided by m sin pi f. In graph it is shown that the frequency response is calculated by applying 11 point and 31 points moving average filter. Moving average filter has very poor low pass filter because slow roll off and poor stop band attenuation. Now we will discuss the relatives of moving average filters. There are two main things involved in it. First is Gaussian filters, and then second is Blackman window filter. When an input signal is passed two times through a filter, it is considered as a filter kernel. But when the passes increases from 2 to more times, then it is categorized as Gaussian filter. This is a contrast of Blackman and Gaussian filter. Gaussian filter and kernel filter both provides better stop-when attenuation than the moving average filter, but one of the disadvantages is that they must use convolution that will have a slow processing speed. Recursive implementation. A tremendous advantage of moving average filter is that it can be implemented with an analog algorithm that is very fast. It has fast, long impulse response. It is composed of sinusoids and exponentials. The impulse response of the moving average is a rectangular pulse, and after impulse response, that is finite impulse response, or FIR filter. Here it is an example. Algorithm: imagine passing an input signal through a 7-point moving average filter. Now we have to design a 7-point moving average filter, and the points that are indicated here is y of 50 and y of 51. When y of 50 is written, we will write 7 consecutive points by considering y of x of 50 as a middle point, by writing equal samples before x of 50 and after x of 50. Before x of 50, the points will be x of 47, x of 48, x of 49, and after x of 50 it will be x of 51, x of 52, and x of 53. Similarly, if we consider y of 51, we will consider x of 51 as the middle point, and we will write equal number of samples before x of 51 and after x of 51. We can also compare it with the formula given here as y of I equals to y of I minus 1 plus y of I plus p minus x of I minus q, where p equals to m minus 1 divided by 2. M is the number of taps. Number of taps mean number of points or filters we are going to design, and q comes from p plus 1. If we want to calculate y of 51, what we have to do, we will simply use this formula, that is y of I equals to y of I minus 1 plus x of I plus p minus x of I minus q. By simply putting the value, we will calculate y of 51. The notice that is given here is this equation uses two sources of data. What kind of data? The previous data and the future data. This is called recursive equation because the calculation is further uses in the future value. This is all. Thank you for watching.